Okay, welcome to the next video in the systems programming video series. In this, we're going to discuss all of chapter 6 because it is a very short chapter. And really, I think we're going to mostly kind of blow through this because there's not much that we need to discuss. So this is kind of introducing us to the concept of assembly language, which is basically a somewhat readable layer you can almost think of it as being in between binary at the lowest level and C, which is a high level language, and assembly is sort of in the middle. So effectively what happens when you compile a C program is it takes the commands that you wrote, the structure that you wrote in C, turns all of it into assembly, which, assembly, you'll see it soon. It's basically sort of commands for placing specific data in specific locations in your hardware. But in any case, so it's I think probably it just makes the most sense to think of it as lower level, that is to say harder to read and more directly accessing the hardware of the computer relative to C programs, but higher level, that is to say more readable than a binary code, which would just be zeros and ones. So the zeros and ones would be what we call machine code or binary code. The compiler translates our high-level C program into assembly and then into binary or machine code. Here they're going to make the case, right? They're going to argue for why you ought to learn assembly directly rather than just living entirely in C. And so, we're going to do it. So I don't know, how much do we really need to be motivated to do it? But in any case, I guess, why would you learn assembly? Well, there are some very subtle behaviors of C code that if you understood assembly, you would understand how the C program is working a bit better, right? So it kind of resolves some mysterious behavior at the higher level. Sometimes you can't avoid it, right? To me, this is maybe the more compelling argument is that very small computers that sometimes are just components to sort of mobile systems or whatever, just don't have the, memory, the space for compiling and, so you basically just have to write in assembly just because of the constraints of your hardware sometimes. Vulnerability analysis, okay, so I guess maybe if you wrote entirely in C, then you could, your programs might be more vulnerable, but if you wrote it in assembly, it would be less vulnerable. I suppose, maybe, I don't understand that totally, to be honest, but maybe we'll see it more coming up soon, or maybe we'll just sort of take it for granted that somehow learning assembly makes you better at designing secure systems, I guess. Okay, I'll roll with it. And then sometimes there are optimization, which I could kind of believe, right? Basically what C is doing is you write it in C, it gets translated into assembly. If you had actually just directly written the assembly yourself, you might have seen ways that it could have been done more simply and using fewer resources than the standard procedure that C is going to do just automatically. So I could believe that. What are we going to learn? We're going to learn instruction set architecture. In particular, I believe what's coming up next is only to learn the x86, but, so as they describe it here. But I think the textbook has, I think, 3 different ISAs, but we're only going to learn that one. But in any case, and it's kind of neat, with simple commands about put this data there and then go to this line of the assembly instruction code. It's very, if you ever heard of spaghetti code, that's kind of what this is, because you say do this and then go to that instruction or something like that. So it'll be interesting to see how do we reproduce the behavior of ifs and loops and various other structures and patterns that we are used to in C. How do they get reproduced at the very low level with much simpler commands? It'll be interesting. So, okay.